Was she in there?
Yeah, she was sitting there.
Oh my god.
Yeah, Isaac thought he
I would
was
be
all,
in that room by myself.
he was ripping
crying.
along. He's like, yeah, I'm gonna get to do it at home.
Nope.
It's up to you guys. This is the notes for the review.
Whoa.
Michael, you're gonna get that test into me at some point, right?
Man.
You better hurry.
Because you're not gonna be happy with your end report when you get it tomorrow.
I'll get it to you. Wait, do you have our test graded for you?
Teachers for interruption. Heavenly Gayhart to the high school office. Heavenly Gayhart to the high school office.
On this.
Thank you.
I'm trying to think what's important on here. I think I put some stuff on here. Just to make sure you know what you use on your calculators for each thing.
Can I just take a picture of it and write it down later?
Sure.
Oh my gosh.
Because I don't want to be slow and actually do that.
Trying to think what,
Oh.
I'm gonna read through them and then I'll probably jot some things down, just because I want to make sure. Normal distributions, make sure you can draw the curves. Guaranteed one of the questions on there ask you to draw a curve, at least one. And you should draw the curves for all of them just to make sure. I know I was doing some of the part of today's assignment, and I had to draw the curve because I kept messing up, couldn't figure out why. The inflection points, don't worry, we didn't do a whole lot with inflection points, so that's not a whole lot. Remember, areas and probabilities are the same thing, so either one of those. If you're using the chart, that's fine. Standard normal distributions, remember that's using the z-scores. So for that, the curve is always going to look 0, 1, 2, 3, and then -1, -2, -3 the other way. We don't have to change everything to z-scores, but we are going to guarantee there's some questions on the test that want you to change from a raw score to a z-score, and a z-score to a raw score. So remember, for a z-score, I'm going to write these two formulas up here. To change something into a z-score, it's the score minus mu divided by sigma. To change it, that's if you want to change it into a z-score. If you want to change it to a raw score from a z-score, then it was x equals mu plus x equals mu plus z times sigma, I believe. Let me look that up to make sure I'm not telling you wrong. I shouldn't have to look it up because we could just do the math there. Let's see. That'd be sigma times z. Yeah, that's right. So that's if you want to change it from a z-score to a raw score. Use that formula. Remember, probability and area are the same thing.
But that formula is from z to raw. The x equals.
This is if you're looking for a z-score.
Yeah.
If you're trying to get a z-score from the raw score, use that.
And then the other one's from z squared raw.
And the other ones, if we're trying to get a raw score from a z-score, we use that. And that's a sigma, not a 6. And some of them you can z-score to raw score. I guess that's right here. We can use the calculator to change back and forth. You just have to make sure that you know what you're doing on the calculator. Use the inverse norm on that. I don't know that using the calculator, on one of them, it seems like using the calculator is harder than just doing the little formula. Make sure you know how to use percentiles. Remember, a percentile might look something like this, P17 with a little subscript. That means, if you wanted to change that, that's 17%. Or if we use it on the calculator, it's 0.17 is our area. Central limit theorem. Central limit theorem, using the sample means. Remember, the sample means is this right here, mu with the subscript, x bar. Remember that the means, this is going to be the same as the mean of the population. The formula for the standard error, that's this, is standard error. That's sigma with x bar as a subscript equals sigma divided by the square root of n. I always forget, you got to find those two things first before you start trying to plug it into your calculator. Once you find those two things, then you can plug it into the calculator using the normal CDF. Be able to explain, and you got to be able to explain. Guarantee there's problems on here that say explain, and you can't just say, because this is 5 or something. That doesn't work. You got to explain it. Remember, if something is unlikely or very unlikely, if it's 2 standard deviations out, more than 2 standard deviations out, then it's unlikely. If it's 3 standard deviations out, then it's very unlikely or very unusual. Be able to approximate using the binomial distribution, decide whether you can use the binomial distribution. Remember, to be able to use it, n times p's got to be greater than 5, or n times q, I shouldn't say or, I should say and n times q's got to be greater than 5. Don't check both. That's the last thing that we did. Don't check both, just check whichever one, p or q, is the smaller. If it's bigger than 5, then the other one's, of course, going to be bigger than 5. If you can't approximate it using the binomial, then you can use the normal, just all this other stuff up here, if they tell you that it's normally distributed. If it's not normally distributed, then we can't do anything. Remember, when we're doing all this with the binomial, what we're actually doing is you're taking something that's in a binomial, and I'm going to write down a couple of formulas with binomial too, just to make sure. If we have some binomial, I could draw, maybe it looks something like that. We're taking it and making it more to fit the normal curve, and so we're sort of estimating this and saying, okay, this part fits in here, and so on and so on. But to do that, if we have something like the probability x is greater than 5, I'm just making up numbers here. We don't, if 5's right here, we don't want to include 5. We want to include everything above 5, so that means we're starting right here and going over. So we're not going to actually start at 5, so that's where we need to change this to x is greater than 5.5, or going the other way. And we have to be able to switch them around and fix that. That's the continuity correction. gotta be able to change that up to fit it. And the two formulas, remember with a binomial, and I forget to do this all the time, with binomial, the mean is n times p, and the standard deviation is the square equals the square root of n times p times q. Sorry, that's sort of ugly. I'm gonna write that up to the side here. For a binomial, if we're using that binomial stuff, then u is n times p, and standard deviation is the square root of n times p times q. So you gotta make sure you don't get this confused, the binomial stuff confused with the mu x bar when we're doing the sample means and all that stuff, or any of the others. And this, you have to find this first before you can use your calculator. Remember CDF on the calculator, CDF means you're starting somewhere. If we're looking at our normal curve, that's terrible, but if we're looking at our normal curve and going down, that's all of that. It's always to the left. PDF means we're just finding one certain number. Trendy, think you can handle all that?
Bless you.
No.
No, 30 seconds left.
Yeah, come on. Maybe 3/4.
Don't reckon what I can handle that.
3/4 is
Oh,
better
you can
than-
handle 3/4 of it?
Yeah,
See, I'm
3/4
hearing
is
like
better
three
than
different
that.
conversations, so I don't even know what Jenna's conversation.
She's just talking to herself.
We're talking about Alex.
I do that bit.
Are we ready?
Yeah.
On the worksheet, so we just want to work through the worksheet together?
Yes.
Number one, and we're going to go quickly because, so you're going to have your calculators out and help me. Number one, make sure I got the right paper here. What is half the area under the normal curve? So if we're looking at this normal curve, half this area is how much? 0.5.
50%.
50% would work. Number two, draw two normal curves that have the same mean and different standard deviations. Describe the similarities and the differences. So if we're going to draw this, got my two, got my two curves. We want the same mean. And you want to make this easy, you don't want to make it hard, so give me a number.
1.
If we put 1 there, what has to go there?
1.
Now our standard deviation has to be different on the two.
You could do like literally 1, like 1, 2, 3. I don't even like all that twos.
So our standard deviation there is 1. This one we could go by 2s. How are the two similar?
They have the same mean.
Same mean. Give me something else.
Oh,
They're both what?
normal curves.
Both normal. How are they different?
Standard deviation.
standard deviations, different sigmas. Give me something else. What's different? And again, don't look at my pictures because my pictures are not drawn correctly. What should be true about this one?
It should be thinner.
Should be more,
Or more wide.
alright, more spread out. One is more spread out than the other. That's what the standard deviation does. So if I was actually gonna draw it correctly, this one should look like this, and this one should maybe look more like
Yeah.
something a little more spread. Number 3. They want you to find find the indicated area, find the area under the normal curve using the standard normal table. So this says using the standard normal table. We could use that. We could use your calculator. We'll probably just use a calculator. So on this, I'm not going to draw my curve for every one of them, but for this one, it says z equals 1.25. If we're on the standard normal curves, it goes 0, 1, 2, 3, -1, -2, -3. We want 1.25, that'd be somewhere about in here. We want the area, and that area is going to be all of this to the left. Does anybody remember on your calculator, how can you find that?
Negative 1 second bars.
So second, bars,
Number 2,
number 2, what's number 2 say?
normal CDF.
Normal CDF,
And then negative 1,000 or whatever number.
put in, and you guys can put in -1,000, that the low limit. What's our high limit this
Your
time?
Z-score.
1.25.
And then,
And if we're using z-scores, do we have to put anything else in?
no.
That's it, if we're just using the z-scores.
0.894.
Anybody else get that?
Yep.
Yes.
Did it right.
And usually we go, if we're going out, we can usually go out 4 spots on these. So instead of me drawing this, does that look like 0.894?
Yeah, probably,
All right, you might want to draw them each time just to make sure that you're doing it right. I'm not going to draw mine each time. Next one says to the left of -0.5. So that'd be somewhere like right in here, and we went to the left.
So you put your high limit.
So what would our high limit or our low limit be this time?
-0.5.
Be careful, we went to the left. -10,000.
Oh, I thought we were going to the right. Oh, wait,
I
no.
think
two.
B says to the left,
Yeah,
isn't
to
it?
the left.
Then -0.5.
0.5.
And it's a z-score, so that's all we have to put in. What's that give us?
Sorry.
0.308.
Give me one more.
Um,
Does everybody agree with that?
Yes.
Next one says to the right. So this time,
Start with your Z-score.
we're at -2.8, somewhere way out here, and we're going that direction. So should we have a big number or a small number relative to these? Should be pretty big, right? Should be almost the whole graph.
And
What goes in here first?
Z-score,
it's
Negative.
2.8.
And our high limit?
whatever, 1,000, 10,000.
1,000, whatever you want to use. What's that give you?
0.997. I don't have that
You don't have another number?
one. Well, I put only 3.
Oh, you mean on your paper already? All right. If we were using the chart, if you wanted to use the chart, remember on the chart, it's gonna give you everything to this way. What would we have had to have done there to get this number? Subtract it from one whole. Next one.
Keep it right again.
And I'm putting these down, sorry. These aren't numbers, are they?
No.
That was A, that was B, that was C, that was D. Somebody just tell me the answer for D.
9.76 times 10 negative.
We gotta go to move the zero.
So tell me how to write that as a decimal.
0.001.
Another 0.
0.
And then 976.
9.8, something like that.
Yep.
Now, if you put, and the book may put something like this, they may put .00, they want to be, they might put a 1 there. That's still pretty close, and as long as I catch on to it, I'd probably count it correctly. Letter E, how do you do in between?
Lower z-score and higher z-score.
So you just put in the low limit and the high limit. This time it's just those two numbers. What'd you come up with?
0.799.
4? F's a little tougher. This time they're doing from this number down this way, and then from that same number up. How are we gonna do that?
I did them separately, like I did the to the left first and then
Okay, so if we find one of them, what do we gotta do to find them both together? Add them up or times it by 2? So somebody do one of them for me. Just do, if we do this one, what's the number? Negative 1.96. So if we go down, negative 1,000, negative 1.96. What's that give us?
0.024.
And we're just going to times that by, what's that give us?
0.04. I don't know. 40.
Anybody get something different? So I got, on my paper, I got .05. So it must have rounded up a little bit. Yeah, try to go out 4 places, that way we can call it.
What is
Be pretty close together.
Then, I typed the wrong number.
Figure it out.
Yeah, I just put the wrong number.
Next one, number 4. Says find the indicated probability used in the standard normal table. Again, these are the same idea. We could use the table. You don't have to use the table if you don't want to. If you just wanted to use your calculator, that's fine. What would you punch into the calculator on this one?
This is where you use the PDF, right?
Do we have to do anything special here?
No.
Same thing. They're just writing it different. So this time,
Oh.
instead of finding the area, now we're finding the probability. But what do we know about area and probability?
Same thing.
Same thing. So you're still doing the same thing. We're just looking at this curve.
Right.
We got 0 here. 1.29 would be, if that's 1, that's 2. 1.29 would be here. We want everything less than 1.29,
To
so
the left.
we're looking at this. So if we're sticking this into our calculator, what are we gonna stick in?
Negative, whatever number you want. And then 1.2.
Do we need the mean and the standard deviation?
Nope.
No, it's 0.9014.
Everybody agree with that? So B, what are we gonna do on it? If we were using the table like it says do, we're trying to find the area out this way this time, so we'd have to figure out the number down subtract it from 1, and then go from there. But if we're using our calculator, what are we gonna put into the calculator for this one?
Higher limit.
Point, or 1.785.
And then like 1,000.
1,000.
Then you get 0.0371.
And again, I would suggest on the test, draw a little graph for each one of these, especially if they're z-scores, because the graph's easy to draw. Draw a little graph and use it to make sure that your answer makes sense. This is about 3 or 4%. So we're saying, okay, there's about 3 or 4% of the data fall that way. Letter C, find probability of the utility bill. Oh, I'm sorry, I'm on the wrong one. What do we put in on letter C?
You get what you can
You gotta do one of them first.
1.05.
Like 1,000.
Do we have to do them separately?
You don't have to.
This time we're looking at, what information are we looking at?
Between
Stuff that's between. So we just need the low limit
the higher
and the high limit. Well, the low limit is negative 1.05. What's the high limit?
1.05.
So you should be able to just plug that into your calculator that way. The only time you need to do them separately is if you're going outwards instead of inwards. What's that give us?
0.7062.
Now D, we need to do what you guys said. We could do them separate. All right, because this time we're looking for, if we look at our little curve, we're looking at stuff out this way, stuff out this way, and we want to put them together. The other thing you could do is you could do 1 minus, and you could find what's in between them, and just subtract it from 1. That's up to you guys. I don't care how we do it. You want to do them separately? The bad thing about doing them separately, if these two numbers are the same, then we just got to multiply it by 2. If the two numbers are different, then you got to do them both and add them together. All right? So this one says negative 2.9 and 2.9, so they're the same. So we could just multiply it by 2. But if they're different than each other, then we have to find them both, and they're going to be different answers. So if I was doing this one, I'd probably do that, and then in my calculator I would punch in negative 2.9 and 2.9. What's that give us when we put that in our calculator?
Between.
What's this answer give us? 9963.
Yes.
And then we just have to subtract that from 1. And if you already got that on your calculator, you could just hit -1. It's going to give you a negative answer, but you don't want the negative, you want just the positive. What's it give you? 0.0 what?
370.
Don't sound right.
37.
Don't sound right.
037.
0.037.
Did I just do that wrong? That's what I had at.
That's what I have on my
on paper.
calculator.
But the calculator said 0.03 cents. So.
Monthly utility bills in the household new pairs are normally distributed with a mean. So the mean is $250 and a standard deviation of $35. So if I'm looking at this before I even start to do the problem or anything, our mean is going to be 250. That's right here in the middle. Help me out. I know that's 285 is next. Somebody, what's 285 plus 35?
That's what, 285?
320, and plus another 35 is 355.
Yeah.
250 minus 35 is 215, is that right?
Yes.
Minus another 35, 180. Minus another 35, 145, is that right?
Yep.
So the curve is gonna look something like that. The utility bill is randomly selected. Answer the following questions. Find the probability that the utility bill is less than 250. So part A, probability that we pick a bill that's less than 250. This one's sort of easy. We really don't need our calculator for this, but we can use it just to show that it's doing the same thing. On our calculator, this time we're going to put in the low limit, the high limit, and then we also need to put in what else? Mean, standard deviation. We want to put in all four of those, unless you want to change everything into a z-score. All right? And if we were going to change it into a z-score, change it to that standard normal curve with 0 and 1, 2, 3 and negative 1, 2, 3. All we'd have to do, we want to change this into a z-score. It'd just be 250 minus 250 divided by the standard deviation, which is 35, which that's going to give you 0, and that's going to be, so the standard deviation, or the middle number here should be 0, and that's the way it works, but we don't want to do all that probably. If we want all the bills less than 250, what's our low limit? Maybe negative 1,000 maybe. What's the high limit? What's the mean?
Mean is 250.
What's the standard deviation?
35.
Somebody punch all that into your calculator and tell me what you get.
25, 0. 0, 0, 0, 0, 0, 5.
Should be 50%, because if we're at the mean, what percentage should be down this way? Half of it. That's why I said that one wasn't, we didn't really need the calculator, but. Next one, probability that you pick a bill and it's between 175 and 225. So we're looking at this. So we're at 175, that'd be somewhere about here. 225 would be somewhere in here. So we're looking for that area right there. So when we're looking at that area, even though my graph might not be drawn, should it be 50%? Should be less than that, right? So when we get our answer, if it's 0.7, we screwed up. Somebody punch that in. How would you punch that into your calculator?
Wouldn't you just put it once again back to your limit?
That's your low, that's your high, 250 and 35. Just punch in your stuff just like that, what they give you.
Point 2214.
2214. Is that what you said?
Yeah. 22%.
So about 22% of the bills should fall in that range. Letter C, probability that you get a utility bill that's more than 275. So X, we want more than 275, so greater than 275. What's our low limit this time? 275. What's our high limit? 1,000. You might even go up to 10,000 because there may be some bills there. Then we put in our mean standard deviation. What's it give us?
0.2375.
Everybody agree with that?
24%.
Letter D, a little tougher on this one, you got a little more to do. If 500 utility bills are randomly selected, about how many would you expect to be less than 220? So we want to find the probability that's less than 220. Let's do that first. What's that probability? What's our low limit this time?
Negative 1,000.
negative 1,000, then put in 220 as your high, 250 as the mean, 35 as the standard deviation. What's that give us?
Or 0.20.
0.20. Now, that's not our answer this time, because they said out of 500, how many would we expect to be less than this? So we take that number times 500. So if you already got that in your calculator, you can just hit times 500, and that's going to tell us how many bills we expect to be less than 220. 98 or so.
Yeah.
We expect to be less than $220. So if you're getting a bill and it's always like 300, what do you know about your bill?
It's high.
Expensive.
It's high for some reason, and you might want to figure out why it's high all the time. At one point, and I probably told you this story, at one point I was getting a bill, and my bill was ridiculously high for like 3 straight months. I mean, it was like $600. And I thought, 1 month, I thought, that's ridiculous, and, made me mad, but didn't really do a whole lot about it. 2 months, I thought, all right, this is sort of stupid. Then the 3rd month, I thought, yeah, there's something wrong. And sure enough, there was. It was my furnace was messed up, and I could have saved myself a whole bunch of money if I thought that the 1st month. Next one, find the corresponding z-scores. So we're changing these scores into, or we're changing this stuff into z-scores. Just changing from one form to another. They give us 0.000 or 3 zeros there. 17. We can do this on our calculator by using the inverse norm. If we're just changing it to a z-score, then for the inverse norm, all we have to do is put in this number in the parentheses and close it. And it's using the chart, but it's using it backwards. What's it tell us?
Negative 3.58.
Something like that, maybe?
Yeah.
So that's the z-score. If we wanted to change that into a raw score, we could still use this, but we put this in, put that number in, then we'd have to put the mean and the standard deviation, and then it would change it to a raw score for us. I think that's the right thing on the calculator. Next one, 50th percentile. Probably won't have to use your calculator on this, but you need to recognize what this is. If we're at the 50th percentile, if we go back up here, we want to change that into an area so that we can use this, right? What would that be as an area?
The percentage.
So 0.50, and then we could just put in inverse norm, 0.50, and it should tell us that our z-score is 0. Letter C, 47.21%. Same idea, we want to change this time from a percentage into a number that looks like that. So what do we do with the decimal?
We move it 2 places.
2 places over, so that's going to change to 0.4721. Then we're going to do all this same stuff. What's that give us?
0.0699.
And you're off a little for some reason.
Is it just 0.6?
No, that's right, but there's something wrong with it.
Negative.
Oh, yeah.
So So that's our z-score. Letter D, they give us 88.1%. Again, we want to bump that over 2 places, but this time it says to the right. So when we're looking at this, zero's right here. We want 88 or 0.881 of the area to be to the right, so that means we're going to be way over here somewhere. So our z-score should be what kind of score? It better be a negative when we get our answer. How can we find that?
Just plug that in after you.
If we do 88.1%, that's going to give us,
Negative, positive, put a negative.
that's going to give you this over here, right? It should give you the same thing. Just to make sure though, what you might want to do is take 1 minus that 0.881, get that answer, and plug it into your calculator. What's the z-score?
Negative 1.10.
And with z-scores, we usually go out 2 places. With the area and stuff, we go out at usually 4. With z-scores, go out at least 2. This one up here, we probably could have stopped it right there for negative 3.58. I'm going to do letter E up here before I erase all this. It has 7.54 between. So this time we're looking at this. We want 70.54 or 0.7054 in between. How are we going to find these 2 z-scores?
Find what's in between.
We know what's in between. What do we need?
Both of those.
We need the 2 ends, right? How are we going to find those?
Well, you minus that from 1.
So subtract that from 1. What's that answer?
That's would be our negative and
0.2946.
positive.
Now, 0.2 what?
946.
946. So does that mean that there's 0.2946 in this little part right here?
No, it's split
No.
between the 2.
So we got to divide that by 2.
And 0.1473.
And then we can use that and just punch it into our calculator just like we've been doing all the rest of this stuff. Put that in there.
You get negative 1.04 or 1.05.
Now, is that just our answer?
No.
We need the positive and the
Negative.
negative, so it's those 2. Number 7, the time spent in days waiting on a heart transplant for people from ages 35 to 49 in recent years can be approximated by normal distribution, where the mean is 289 days. 289 days, is that right? Yeah. And the standard deviation is 17.8 days. So if I was going to draw this little graph over here, and I'm not going to draw it very well, 289 would be right in the middle. We're adding about 18 each time. So 18 each way on each one of those. Or subtracting it if we're going down. We could find those numbers if we wanted here in a minute.
Go on.
Well, waiting time represents the 20th percentile.
God.
So part A, we want the 20th percentile. Well, 20th percentile, what is that? Is our area? Tell me a decimal. for that.
0.20.
0.20. says what time represents the 20th percentile. So we just want to know the time. What we're going to do on this, we're changing this number into a raw score. What we can do is use the inverse norm on our calculator. We don't want to put in just the area like we've been doing because we want a raw score. So we put in the area, which is 0.20, and then we put in the mean and standard deviation. 289 and 17.8. And that's going to give us out the raw score. That's going to give us out the score that fits what we're talking about in our data.
It's just 274.
274?
Yeah.
So what's that mean? Explain that to me. 274 what?
Days.
Days.
You're waiting for a mark.
So if you're in the 20th percentile, you can expect to wait 274 days for the heart transplant. Part B, what waiting time represents the second quartile? So second quartile. Anybody remember anything about the second quartile?
It's the mean.
That's the mean. So what number represents that?
289.
289 days. We could have used the inverse norm again and know that the area is 50%, or we could have just realized that it came out that way. Number 8, given the population has a mean of 225 and a standard deviation of 40, find the mean and standard deviation of the sample means. So this time we'll find the sample means, the mu sub x bar and the standard error, which is sigma sub x bar. Part A, how do we find the mean? Mean of the sample means and the mean of the population are the same. So what's the mean here? 225. And I wrote standard deviation. That shouldn't be standard deviation. I gotta fix that. That should be standard what?
Error.
Should be standard error. I think I mentioned that I mess that up all the time, didn't I?
Yeah.
How do we find the standard error?
The square root right here.
You take the square root of the sample size, but it's.
That goes on bottom, right?
Yeah,
it's
on
like-
the top is the standard deviation.
So this time it's square root of 500, and on top it's the standard deviation, which was 40. Somebody do that math for us.
10.06.
What should always happen with this standard deviation and the standard error?
Oh, you did it wrong.
You did?
Oh,
Yeah,
yeah.
it was supposed to be 40.
Oh, I put 2.0.
Yeah,
My
it's-
bad.
I was
Hold on.
gonna say, that's not what I
1.78.
have on my.
I got scared.
What is it?
1.78, 1.9 around.
1.9?
Yeah, or 1.8.
1.8? Is that right?
Yes.
Yeah, that's right now.
What should happen from standard deviation to standard error? Should go what? Should go down, it should be smaller. If it's not smaller, then you did something wrong. Next one, if the sample size is 1,000, what's the mean?
225.
That stays the same. Standard error,
Oh, gosh.
You still do 40. and then you
40
just-
over,
Which is 1.26.
number 9.
Got me now.
For a sample of n equals 64, find the probability of the sample mean being less than 24.3 if mu is 24 and standard deviation is 1.25. So mu is 24, standard deviation is 1.25. Before we can stick anything into our calculator, we've got to do this first. We got to find the mean of the samples, and we got to find the standard error. Please make sure you remember to do this. If you don't remember to do this, then you're going to get the wrong answers. What's the mean? 24, that's the same, so that's not hard. Standard error, we take our standard deviation, we divide by, what was it in this time? 64. Divide by the square root of 64. What's that give us?
Am I wrong?
1.5 or 1.6.
Yeah, probably at 6.
1.6?
Round up.
Is that right?
Yeah.
Now, if we're gonna do that, once we have all that, we've changed everything in, or to fit that new curve for the sample means. So now we can use the normal CDF on our calculator. What things do we need to put in for norm CDF?
Don't we need the low
Low limit, high limit. Now this time, instead of just the mean, we want the mean of X, but they're the same thing, but we also want the standard error. So you gotta make sure you're putting in those two things. You're not putting in just these two. You gotta switch them to be those two, which the 24 is the same, but the sigma's not the same. What is our low limit this time? Negative 1,000. What's our high limit? 24.3, because that's what they said.
Oh, okay.
We want to go, we want everything less than 24.3, right?
And then 24.
Then 24 is our mu, and what's our standard error? 0.16.
And it comes out to be 0.97.
0.97.
Yes.
Go out any farther?
It goes 0.9696.
I got something completely different.
Hell no.
Anybody else get that same thing Isaac got?
Yeah.
0.9696?
Yep.
We'll go with that. Oh, I put in a different standard error. I didn't round mine off as much as you guys did. Survey of U.S. adults 18-29 found that 93% of use the internet. You randomly select 100 adults ages 18 to 29 and ask them if they use the internet. Find the probability that exactly 90 people say they use the internet. So part A, we want probability X equals 90. First thing, before we do all this, to do this, we need to check, see if it's a binomial or if it fits a binomial setup that we can use. What's our P this time?
I mean, like, just
Probability.
50. Well,
Look at what they tell you. Where do you find the probability at on this?
there's probably a say yes or no.
Yep. So what's P?
93%.
93%. What's Q then?
7%.
0.07. N, how many are we taking at a time?
Random sample 100 adults.
100. So we have all that. First thing we need to do before we can do any of this is we need to figure out what the mu is. Remember, mu is just N times P. So that's 0.93 times, oops, I did it backwards. Is that gonna screw anybody up? So, because I put P first. N is 100.
Nice.
What's 0.93 times 100?
93.
93. Sorry, I started to put a point there. That's not supposed to be a point. And then we also have to find our sigma, our standard deviation, which is the square root of N times P times Q. So that's going to be 100 times 0.93 times 0.07. What's that give us? And I messed this whole problem up, and I'm going to explain it here in a second.
6.51.
6 point what?
51.
Now what I forget to do on this?
Okay.
We need to check, see if it works first of all, right?
I gotta take the square root of it.
So, oh, you didn't take the square root of that?
2.55.
2.55.
Yeah.
To check it, we take N times P and Q times P, and they both have to be larger than 5. Do we really have to check both of them?
No.
Which one are we going to check?
We don't really have to, but that one.
The smaller one, right? If the smaller one's bigger than 5, then we know the bigger one is. So what's 0.07 times 100? 7. Is that bigger than 5?
Sure.
So then it's going to check out, it will work as one of the binomial setups. So we have all that. Now we're just going to use our calculator. Here you got to be careful because this time we're not finding a high and a low limit. We just have one number, so what are we using? We're just finding one thing.
You're just using the first number, PDF.
We're just using PDF instead of CDF. So what were the things that we had to put into our calculator? Anybody remember?
90.
Put in the X that you're finding, right? Then what?
Just the
So you do normal PDF. This time we're putting in 90. Mu, which was 93. Standard deviation, which was 2.55. What's that give us? 0.078.
Yeah.
Anybody else get that?
So like 8.
Almost 8%. Next part says, find the probability that fewer than 90 people say they use the internet. We already did all the hard stuff up here.
So we can use normal CDF.
So now we can use the normal CDF or norm CDF.
Did we skip B?
Oh, I did skip B, sorry.
At least 90%.
At least 90. So I'll write that out here, my fault. Find the probability at least 90, so probability that at least 90 says X is greater than or equal to 90, right? At least 90, that's 90 or more. So we gotta fix this now. Watch closely on this because you gotta make sure because this is gonna mess up your problem. So if we're trying to find the probability X is greater than or equal to 90, remember, we're fitting this to a binomial setup. So if we're on our graph, and 90 is right here, and we got 91, 92, 89, and our bar for 90 is this bar, let's say. We want it to be greater than or equal to 90. Are we going to start right here in the middle? No, we got to start over here and go up, right? So this time it would be, so this changes to probability that X is greater than 89.75. 90.5. What if it just said probability X is greater than 90? Then we just want the stuff above 90. Would we start here in the middle?
No, we just start at 90.5.
We'd start at 90.5. So make sure you can switch that over, do that conversion. Now when we punch it into our calculator, now we can put in high limit, low, or low limit, high limit, mean, standard deviation. What's the low limit this time? 89.5. What's the high limit?
Or 100.
No, it's
Or it could be
90.5.
How high do we want to go up to?
Oh,
Do like
yeah,
1,000.
1,000. We want something bigger than everything, right? What's our mean? 93. What's our standard deviation?
2.55.
What's that give you?
Oh, that's what I did wrong.
Again, while you're doing that, watch, I'm going to draw this up here. Our mean is 93, so that's right in the middle. We're going up about 2.5 each time. Down about 2.5 each time. 89.5, let's just say we're going up by 3s each time. 2.55. So 96, 99, 102, 90, 87, 84. 89.5 is going to be somewhere about here. We're looking at this area. Should it be a big area or a small area? Should be sort of big, right? What'd you come up with?
0.915. So it is pretty big.
So about 91% of the data. Does that make sense to our graph? Yeah. And you might want to draw every single time. If you look at my papers, every time I draw a little graph, and this one I didn't, I drew it off to the side somewhere. Because I want to make sure that it's making sense. I'm going to erase this so I can do part C. I wasted a lot of space. Part C, find the probability that fewer than 90 people say that they use the internet. So this time I want probability of X is fewer than 90. A couple different ways we could do it. We just found the probability that X was greater than or equal to 90. We just found that, so we could take that answer in part B, subtract it from 1. Or we could change this, do that conversion. If we want less than 90, I'll look at my graph again, and 90's right here. This is my bar for 90. Do I want to start here?
No,
We want less than 90, so we're going to start here.
at 89.
So that's going to be 89.5, right? So when we go to plug it into our calculator, we want everything less than that. What's our low limit going to be?
Negative 1,000.
-1,000. What's our high limit?
89.5.
What's our mean? Ignore that line going up there.
93.
And what's our standard deviation?
2.5.
And again, what are we using? What are we using on our calculator?
Normal CDF.
Normal CDF. We could use the binomial stuff if you wanted to go back and do all that, but it's easier to use normal CDF. What's that give us? Everybody agree with that?
We really could just take the top one and subtract.
So we could have took letter B and subtracted from 1, and we should have got the same answer. If we didn't get the same answer, they're doing it 2 different ways, then we did something wrong. Your assignment for next class. I was hoping to get a whole bunch of this done, but we're not gonna get as much of it done as I hope. Most of it, I think the first like 28, no, the first 34 took me like 15 minutes. So about half of it took me a total of 15 minutes. Because they're pretty easy. Looking at number 1 real quick. Says use the graph to estimate mean and standard deviation. What's the mean on graph 1?
I didn't bring my book today.
Oh,
I thought we were gonna have a test.
we could still do that.
Huh?
Huh?
We don't have enough time to set
Yeah,
up
we
stuff.
do.
8 minutes is enough.
I thought we were gonna have a test, so I didn't bring my book.
What do we do? Find the mean.
Just look at the center of the
293. Just look at the center of the graph. So, go over there and share or something real quick. Somebody help me out so we can meet quick.
Find the page.
It's right after 292.
Number 1.
That was funny.
What do you wanna find?
Mean,
The middle. I think.
standard deviation.
5.
Be careful now, because they did their numbers. I don't like when you do your numbers that way, but little dotted lines.
Oh.
It's
What is that, like
4
9?
point.
Just make it a whole number.
Like
4.
3?
3.
Three.
That's
All right.
I don't know why.
That's what they want. Yeah, I don't like it when they do that again. 2 you could probably do yourself, right?
Sure.
Jump down to 3 real quick. Which normal curve has the greatest? The greatest mean. 1 or 2?
Oh, 2. Or 1. 1.
Which normal curve has the greatest standard deviation? Again, they drew their curves and they did exactly the same. How many standard deviations resistors are? So they give us this on number 5, 1.32. That's a raw score. What they want us to do on each one of these is change them into z-scores. We'll do a couple of these just because I want to make sure that you know how to change the z-score. So we're taking the z-score. All we do to change that into raw scores, or change this raw score into a z-score, you take the score that you're looking at, minus the mean. This time they tell us the mean is 1.5. And divide it by the standard deviation, which this time in the directions up there, they tell you it's 0.08. Somebody do that math for us real quick.
Negative sun's equal.
I got negative 2.25.
That's what I got.
I believe it.
Make sure if you're doing this, you gotta do the top first, then hit equals, then hit divided by. So that's changing this from a raw score into a z-score. Remember that formula is just z, get rid of that, z equals x minus mu divided by sigma. Think you could handle that on all those?
Yeah.
So look at back to number 5 real quick. Number 6 asks you if any of them are unusual. What's going to make any of these z-scores unusual?
If they less.
Was that z-score unusual?
Yeah.
Yeah.
Yeah, so if it's 5%, but if it's more than 2 standard deviations away from the mean, anything more than that is considered unusual. So that one would be unusual, and maybe some of the others would be unusual also. Look at number 7. They give us a z-score is 0.46. We could just use our calculator if you wanted. There you just do a normal CDF. What's the low limit on that blue there?
-9.
High limit? 0.46. That's in the positive, right? So if
Yeah.
we're doing positive all the way down this way, our area should be more than 50% when we get it. Do we need to put in a mean and standard deviation? No, because we're just using the standard normal curve.
And it's 68 or 0.68.
You ask for it, Mr. Ebersole? Up there, where you tied it?
Oh, no, just, it stretches out and I tie it to keep it tight. Number 8, you can probably do. Number 9, we did a bunch of those. You're just doing the same thing, using their z-score. Trying to find some here that maybe are a little different. Yeah, they're mostly all the same. World's smallest mammal is the kitty's hog-nosed bat. You guys didn't know that?
You ever seen a hognose snake?
We're not talking about hog-nosed snakes,
Okay,
we're talking
they're
about
very
hog-nosed
stupid.
bats.
Don't they have a little lip? They got like a little snout. It's.
So do that.
Their fingers are like.
I'm probably not gonna collect this, but this would help you review for your test.